everyone, this is Anugrah Rao. Welcome to the 57th episode of Microsoft Art of Code, brought to you by Millionlights. Millionlights is a TV channel dedicated to improving skills of people and their employability. Now, let me tell you more about Microsoft Art of Code. Microsoft Art of Code is a series of lectures, courses, and talks by experts who are going to discuss the latest Microsoft technologies, topics related to programming, and industry forecasts that are all focused on employability. This course is basically for people pursuing computer science. This content has been created by our partner Microsoft. And today we have Christopher Harrison and Suzanne with us who will be discussing everything you need to know about creating website with Python, Flask and SQL. Create, configure and connect to SQL databases. Learn to structure your code, check out advanced UI options, find out what Jinja templates can do for you, and get started with Bootstrap. Get the skills you need to publish a professional website and level up your Python and Flask knowledge. Now let's move towards the course. In the previous course, we covered design of a Flask application. In this course, we will cover object-oriented programming, and after that, we will move towards introduction to relational databases. So let's get started with object-oriented programming.
So let's start off by talking about object-oriented programming and what exactly is an object. Well, an object represents something, and the reason that I use a very generic term there is not because I couldn't come up with something more creative, but because I didn't want to constrain it at all. Because that's it, is that an object represents something. So it could be a real world entity. So it could be a customer, a user, a product, a category, whatever it is. So it could be something tangible that you're trying to model your application around. Or it could also be some form of a logical entity. So maybe it's something that's going to go back and forth between a backend database and your application. Maybe it's going to be a wrapper for web service calls. Maybe it's going to be something that's going to do error logging for us. So it's going to be, something. And that's exactly it. And so when I like to think about objects, I like to think about them in that exact phase, that it's something. Think about it as something tangible, like a marker. And I always love the marker example. When I was in the classroom, I always just loved that marker because I would literally hold it up and say, here's my object. So an object is a noun. It's something. It's something that you can use in some way, shape, or form. And again, it could be logical. It could be something that's tangible, but it's something. That's your noun. Now, we're going to turn this into a slight English class here, or a language class, I guess, to be a bit more generic. And every noun that we have is going to have two things. It's going to have actions or verbs, and it's going to have properties or adjectives. So a property or an adjective is something that can be used to describe that object. So if we take a look at our marker, you're going to notice that our marker is red. So it could have a property of color that would be set to red. And you're also going to notice that objects will have verbs. And those verbs are going to identify the actions. Those are also known as methods. And so, for example, it might be write. Now, here's where things can sometimes get a little bit confusing. That people always ask, where do I put things? And in particular, where do I put the methods? And the way that I always like to think about this is by telling an old joke. Are you ready?
Oh dear. Okay.
Here
All
we
right.
go. It's an old joke. How many object-oriented programmers does it take to change a light bulb?
I don't know, Christopher.
None. It changes itself. Okay, look, I didn't say it was a funny joke. But the point that I'm trying to make, I built that right, I knew. I didn't say it was a funny joke, but I always remember that because that sort of helps guide where we want to put the method. Put the method onto the entity that knows what's going on. So put it right onto, in the case of our marker, put it right onto the marker. So it's not going to be person.write, which is sometimes the way that we would think about it in logical terms, because I'm going to write. And then what winds up happening is I'm going to create another method over here that's going to use the object where that method should be on the object. So put the method on the object. And as a perfect example, keep in mind that you've already used objects, that strings are objects. And strings have methods that are going to impact the string. So if I say name equals Christopher, or Microsoft CEO Satya Nadella, I can then say my name variable dot upper, and that will then convert that into all uppercase letters. So rather than having something like I'm being very creative here, dot upper, and then putting inside of that my name, rather than me doing that, you'll notice that we just simply say dot upper on the object itself. So even the developers at Python had heard this great little joke about number of object. Again, I didn't say it was a funny joke, but that's always the way that I think about it, that you'll notice that objects take care of themselves. Now, the other big component about an object is that they're self-contained black boxes. They do something, but we don't need to know what goes on behind the scenes. The analogy is I can drive without having to understand how the internal combustion engine works. I can't even change my oil. I have no idea what happens, but I can successfully drive an automobile because it's a black box. And to, again, bring that into what we've been doing, I don't need to know behind the scenes how Python is accepting the HTTP request and sending the response back out the door. Or going back to the first class, how it was actually sending something out to the screen, how it was reading from a file, how it's actually calling a database behind the scenes. Do I need to know how any of that happens? No. All that I have to do is go find the right object and say, hey, Mr. Object, can you please go do your magic and go do whatever it is that you're supposed to do? And that's it. And so you're going to notice that about all the objects that we use that when you're looking to create your own objects. Again, going back to Jonathan Edwards, assume that you don't know how to do it. Do what other people have done. Look at what other people have done and use that to drive your design. Now let's have a little fun with terminology here. And let's start defining two terms here, class and actually object. So let's start off by talking a bit about a class. A class is sort of like a blueprint. I love that analogy.
It is a great analogy.
It is. That what a blueprint is going to define is it's going to define the dimensions of how a house is going to look. It's going to define where our doors and windows are supposed to go. It's going to define the size of the rooms. It's going to define the number of bedrooms. So it's going to define that entire layout. And that's exactly, in turn, what a class defines. So a class is like a blueprint. And just like a blueprint is going to be used to create a house, a class is going to be used to create an object. So my class is going to define functionality. It's going to define those properties. It's going to define what it is that when we create an instance of it, that it's going to be able to do. An object, then, is an actual implementation of the house. Now, kind of bear with my little graphic here. We actually kind of looked for a real simple little graphic that we were going to be able to use, and that was about the best that we could find. And yeah, it's pretty bad. We admit it. Yeah, thank you. Trust me, it's better than I could draw, as you've clearly seen. But the point is that house is then built from that blueprint. Now, each house can have different colors, different flooring, different appliances, different finishes, so different like countertops and things like that, but it's all based on the same blueprint. So if we use a blueprint to build a house and that blueprint says, hey, you're gonna have 4 bedrooms, then you're gonna have 4 bedrooms. That's what you're gonna have because you're using the blueprint. But you can decide what color you want those bedrooms. You can decide what wallpaper you want to use if you're gonna use wallpaper. You can decide whether or not you want hardwood or laminate or all of those individual components that are going to make that house unique. It's the exact same thing when we talk about classes and objects. So my class is going to define what an instance of an object is going to look like, and then the actual instance is going to have different properties. So it's going to have a color, it's going to have a name, it's going to have, whatever it is that's going to make that particular instance unique. Now, where we start to get into things that are a bit more fun as far as terminology goes is, unfortunately, we as developers don't always use the words correctly. Now, I try hard, and Susan tries hard, and there's a very good chance that we're going to be technically incorrect at some point. That at some point, one of the two of us is going to say class when we mean object, we're going to say object when we mean class, and every single developer does it. And in fact, when Susan and I were developing these slides, and I want to give Susan full credit for this, because she was very specific about making sure, as we built these slides, that we used the correct terms, because it is kind of important, and you do want to try and get yourself into that habit. That I always go back to the golf analogy, and I'm a perfect example of this. Is I learned to play golf just by going out, picking up a club, and to start swinging. So I learned a ton of bad habits. And then when I went to go and take lessons, by the time that I got back out to the course, unfortunately, those bad habits were just too ingrained. And so when you're under pressure, you fall back to what your brain already knows, and so then I just fell right back into this wicked slice. And so that's sort of the problem here, because I didn't learn it right up front. And so whenever my brain is under pressure, you go back to whatever it is that you first learned. Same concept here. So if you start from right now, if you've never done object-oriented, if you start from today, using the right terms in the right places, you won't wind up like Susan or I, that you're going to start using these terms properly all of the time, or hopefully you will. So you just have to kind of bear with it, that sometimes you are going to notice that many developers, including the two of us, are going to use those words interchangeably. On top of that, the word property has a lot of other names, and in .NET actually, property means something very specific. So sometimes people will call it a field, sometimes people will call it a data member, sometimes people will call it a property. And again, it's just one of those things that you just sort of have to kind of roll with, I think is about the best way to describe it. Okay, again, enough concepts. Let's get in and start looking at code, and let's take a look at how Python manages its classes. So the way that you create a class in Python is by using the keyword, wait for it.
See, so Python knows which word to use.
Yeah, exactly.
It's just us who has the trouble with it, really.
Yeah, exactly. So you're going to notice class, and then you're going to give it a name. And again, I was very creative here with demo object. And this is just part of the syntax. And that's just simply the word object. It just needs to be there. So it's going to be class demo object, and then in parens object, and then you'll notice the colon, and then we've got the definition underneath there. So name of the class, paren object, and that's what you're going to create. Now methods are just like functions, and this is something that you've probably picked up in my speech, is that I use the terms methods and functions interchangeably, and I think most people do that. I don't think I'm alone in that. And so remember, a method is going to be the action, and remember the light bulb changes itself. You graph that onto the object itself. So they're added just like functions. That if we take a look here, and I'm just going to kind of cross something out here. If we take a look, you're going to notice def name, and then there's a colon at the end here. And then you're going to notice, I'm just crossing something out, that there's def name and then a colon. And so it really is just like a normal function that we've already created.
Yeah, no,
nothing special.
That syntax, if you look at it, take out that word self, and that is the exact same syntax we use to declare a function in Python. Mm-hmm. Yeah, the only difference is this is a method inside a class, so there's a little extra syntax we have to remember.
And that's where self comes into play.
And this is a Python thing.
This is a Python thing. And other objects have sort of a similar keyword. They don't necessarily have a similar syntax, I don't think, but they have a similar keyword. And that is something to represent the object itself. That in curly brace languages like Java and JavaScript and C and C#, they use the keyword, I guess I should say C++ rather than C, but in any event, they use the keyword this to represent the current object. And in VB, they use the keyword me. Mm-hmm. And in Python, and I've seen this in a couple of other languages as well, they use the keyword self. Now, self will give you a reference to the current instance of the object. So remember that a class can be used to create instances. So imagine, if you will, that we had one instance here, and we had one instance here, and we had one instance here, that when we're inside of when we're inside of a particular method and we say self, then we're going to be referring to whichever object it is that the user is using. So remember that when you create an object, you're going to put it onto a variable. And so you're going to say whatever that variable name is. I'm going to call it V because, again, I'm creative. And then whatever the name of your method is, when you have self inside of there, it's going to refer to that current instance of the object. So that's what self is all about. And again, it's just part of the syntax. Self needs to be there. Now, let's go back to our blueprint. We're going to kind of belabor this analogy here. That when we put together the house based off of that blueprint, we're going to construct that house. We're going to construct the object. So classes can have constructors, and constructors are used for initializing, note that word, initializing the object. So it's going to be all the information that we're going to need to create a new instance. So if we were creating a class to represent a user, we would need a name and an email. If we were doing something for a book, we're going to need a title and a description. So we need to potentially ask the user for some information, and we're going to do that just by having a list of arguments, or maybe we just simply need to go in and set a couple of things up. That what you're going to notice in my upcoming demo here is that I'm going to take all of our Redis code and I'm going to keep it working, and what I'm going to do is I'm going to put it into an object. Well, when I put it into that object, when I create that class, I'm going to need to make sure that we connect to Redis. So I'm going to need that connection string, and again, I only want that one time. So I'm going to put that into the constructor. And the way that we define a constructor inside of Python is by using the syntax of underscore, underscore, init. And you're going to notice a similarity there, that just like when we created the package and we had init.py, or underscore 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 pi. Same concept here, that you're going to notice that it's underscore underscore init underscore underscore and then the rest of it. And so what you're going to notice right here is that we still have self just like before, and then we have whatever arguments it is. So it really is just like a method. It's just the name that's going to be different. You can then add properties on by just simply adding them in as data members. There we go. Let's zoom it back. So you can actually set this up in two ways. That you can create properties that are going to be shared across all instances. So for example, an interest rate. That let's say for our little sample here, that the interest rate was going to be the same across all bank accounts. So we don't want to define that multiple times because it could potentially change on one and not another. So we can set that up so it's going to be shared across all items. Or we can tie it to a specific instance, sometimes known as an instance data member or an instance property. And that would be, for example, the balance of a bank account, because after all, not every bank account is going to have the same balance.
Right, because if you and I both have a bank account, it's the standard savings account, we're both going to have the same interest rate, but each of our bank's account is one instance of a bank account, and my balance isn't going to be the same as your balance.
Exactly. Now, the last little thing to note here is that you can also create items that are private as well, which would mean that anybody that's outside of the object or outside of the class is not going to be able to access that value. And then the problem, of course, becomes, well, how do we expose that out? And you create what are known as accessor methods. So you would say get name, set name, and then inside you would have a private name that you control. And we'll actually talk a little bit about why you might decide to do that when we get into encapsulation later on in this module. But since we just sort of are trying to define properties, I wanted to throw that in there. And then you'll notice that I've got a set of examples here. Now, you'll notice that the difference between a shared property and an instance property is one word: self. That's it. So remember again, self is the current instance of the object. So if you want to create a property, you just simply say whatever the name of the property is and just graft it right onto self. Some people actually call that duck typing in JavaScript, and it's sort of that similar concept that I can actually just have a JavaScript object, throw a property onto there and set a value. You're kind of doing that exact same thing here, that you've got the object and you're just going to throw a property right onto it. And so we just simply, again, just self, or if we want it to be shared, we just don't use self. And if we wanted it to be private, you're going to notice that it's underscore underscore, but you're going to notice that the difference between the two is the existence of the word self or not self. All right. Let's take a look at some code.
Yeah, I was going to say, it's a lot of theory.
It's a lot of theory.
Sometimes
yeah.
it's hard to sort of figure out how you take that back out again and apply that to your code. So, you know, we got the idea, okay, classes are our blueprints, you know,
Yep.
the objects as the instances, we have methods, and we have these different properties that we can declare that are either just are available for all the instances or for a single instance. So yeah, let's see how that sort of falls in.
Perfect. So here's what I'm going to do is I'm going to come back to the app that we've been building on, and I'm going to right click and I'm going to say add new item. And you're going to notice that there is Python package. So I'm going to actually go about it this way. I'm going to let Visual Studio do a bit of work for me. Last time, of course, we did the underscore init. So I'm going to go in. There's my, my little package. And I'm going to give this a name of models, like that. And so what you're going to notice is that it will automatically now create that underscore init underscore py format. Now, if there was something that you wanted to do inside of the initializer here for the package, you could. But you're actually not required to. And in my case, there's really nothing that I want to do because this package is just going to be a container for my data access code. So there's really nothing to globally initialize. So I'm just going to leave it alone, and I'm just going to right-click on models, and I'm going to say add, and I'm going to say new item. And I'm going to choose Python class. You could actually just go with an empty Python file. And I'm going to call this my Redis client, which is spelled like that.
So the advantage of picking Python class is Visual Studio writes a little bit of a template code for you. There
Exactly.
You go.
Yep.
Yeah.
Just like that. Okay. Now I am going to case this. I do prefer Pascal casing on my classes, and you could, if you wanted to, give a description. So I prefer the traditional comments. That's just me. And so I'm just going to say client for connecting to the trivia Redis database, just like that. Okay. Now.
So you're creating the class. Got it.
Yep. Now we've actually already done this code. So let's just go get the code and migrate that into here. So I'm going to start off by saying def underscore init and underscore and self, just like that.
So this is a constructor you're creating here because you're using that special name init, which sort of mentally you can use to trigger the word. It's initializing, sort of setting up my object when I create a new instance. So that's your constructor method.
And that's exactly it. And so inside of there, I want to create the connection to my Redis database. So what I'm going to do is I'm going to go over to views here, and then there's that little bit of code right there. So I'm going to live on the edge here. I'm going to cut that right out of there. No going back now.
So you can't copy and paste, but you're allowed to cut and paste.
You're allowed. Oh yeah.
There we go.
Cut and paste I'm all about, but yeah, copy paste. Whoa, is bad. Oh, you stink.
Control Shift will cycle back through the keyboard. There we go.
That's okay. I'm just going to do it the old-fashioned way. There we go. Yeah, we actually, Susan and I did a full-blown MVA on Visual Studio 2013 tips and tricks. Go check it out. And that was one of the things that, yeah, there's all sorts of cool little shortcut keys. Go check it out. And even if you are, not doing .NET, there's still a lot there, especially in that first module that you could pick up on.
And specifically what I was giving Christopher a hint on there, just in case you're like, what's she talking about, Control Shift? If you do a copy paste or a cut and paste, and then you paste and realize what you wanted to paste was a couple back, if you go Control Shift V, Control Shift V, Control Shift V, it'll actually cycle backwards through the clipboard, which is a handy little trick in case you want something you pasted a minute ago back.
Absolutely. Yeah, just like I wanted that back. Okay. Now, what you're going to notice is what I did is I just took that constructor code that we had, or the connection code that we had, and I just pasted it right into here. Now I want this to be available for just the current instance of the object. So again, the way that we do that is by saying self dot.
Right, because that changes where it's available. So that's the one, that was like the account balance on the bank.
That's exactly it. That's exactly it. So I'm going to say self.r, and we'll just attach that right on. And so now let's go ahead and let's go grab this little bit of code right here.
Which was the code we wrote in the last course that would write our question and answer that someone typed in and save it to Redis.
Yep. So this is going to be my save. So for right now, I'm just going to put in a comment for myself. Note to Christopher. I do often leave notes to myself. So note to Christopher, add in call to save method here. Okay. So let's remember that. So now let's go ahead and come on over here, and let's go ahead and say def, and let's go ahead and say save question, and let's say for right now I'm gonna sort of build this iteratively.
Okay.
So we'll just start off with save question and self. And that's it.
We know we need to have a method, and we want to call our method save question. We know we need that self keyword in the parameters. That's a requirement of Python.
Yep.
We're writing our code that's going to save some values to Redis.
Exactly. So let's just go ahead and do a real quick update. So we just took that exact same code, and now I'm just going to use that self dot, because again, that's where R is. And remember, R was the R. R was the
Talk
variable.
like a pirate day.
It is. It's that variable that we use for Redis. So we're going to say self R set, and then the title and the question, title and answer. Now here's a bit of a problem: is if we go back to our views py, we had our title and our question and our answer.
Yes, and we had that value there, but obviously if we're now over here in this code, it can't access those variables you had over there. So you need a way to pass that question and a value for the question and answer to this class so that we can save it to Redis.
Exactly. So I'm just going to add those in as normal parameters. So we'll just go in and say title, question, and answer. Now everything lights up, if you will, to gray, showing me that all of that is there. So now we've got our save question. Okay, cool. So now let's go back to our views. Let's kind of keep moving code on over into there. All right, so now we need the ability to load a question. So let's go ahead and cut that code. And again, note to Christopher, add in call to get question here. There we go. And let's again def, and we'll say get question self title. Whoops! No, I'm already cheating. I'm getting ahead of myself.
That's right. You were going to do it piece by piece.
And let's go ahead and paste that in. And there's our little question. Now,
that's the code that's retrieving the question back from Redis.
Exactly. Yeah. So what we really want to do here is just simply return that back. That, this is one of those things where. Let me do this. I'm going to say return question, and I know that I think we've sort of talked about this in the past. Is you could actually write the code like that, or the other thing that you could do is you could also just simply say return self r get title plus.
Yeah, and this falls into the category of there's always a lot of different ways of doing things, and it's a personal preference. Some people love putting everything into one line of code. Some people like to break it up because they find it easier to follow. This totally is personal preference.
What do you like?
In this situation, because it's a fairly complicated one, I would probably do it over 2 lines.
Okay.
But if it's a really simple line, then sometimes I do put it in the return statement.
Done deal. You've made the decision.
All right.
Okay. And then I'm just going to go in and say title, and away we go from there. So that's going to be get question. So we'll load it up and return it back. And then we also need to go get our answer. So once again, we'll cut. And then note to Christopher, add in call to get answer here.
Okay.
Cool. And so now let's go ahead and come back over here, and let's say def and get answer. It's a silent queue. And self and boom, and return answer. I'm just going to use the exact same thing. And then one more time, title. Okay, so now here's what I want you to notice. Is I took all of that code that we had inside of our views and I put it into the object. Now, could I have just sat down and typed out this object completely from scratch? Yes, I could have. I could have just and banged it all out in one shot. The reason that I took the additional step as part of this demo of migrating the code over is because what I wanted to show you, and we know that this code works, we've proven that earlier in this module, we know that this code works. What I wanted to show you is that we're not doing anything different. The only thing that we're improving here is the design, and we're just breaking it up into more sensible chunks here. So that way later on, when Susan takes over and she starts doing SQL, that we can more easily migrate this into doing SQL.
Right. We're not actually executing any different code than we were executing before. We're executing the exact same code. But what we're trying to do here is think about what we've talked about in Module 1, about how do we structure our code in an intelligent way? How can we put our code in one place so that if we need to make a change, we just go there and change it?
Yep.
So we're taking this code, we're moving it to the class, so it's going to be more maintainable code, better structured code going forward, because we know there's going to be changes coming. And this is the type of code that's going to change. We're going to put that over there in a class, and later, miraculously, we're going to change that code.
Yeah. Okay, so let's come back over here into our little code. So now, I don't need Redis anymore inside of here. So I'm actually just going to comment that out for...
Yeah, because you put all the Redis code into your class.
I'm going to change my mind.
You can take it out.
I'm going to live on the edge. I'm going to just take it right out.
Because you're not using that Redis code here. Your Redis code is really inside the class.
Exactly. So now what you're going to notice is that I'm going to go grab that Redis client. So I'm going to say from trivia MVA app.models .Redis client, I'm going to say import, and then that Redis client that we created.
Right, so that's the new class that we have just created.
That's exactly it. And so now I had some notes for myself down below. So let's call that save method. So I'm going to say client equals Redis client. That's what I called it, just like that.
So now you're creating an object.
Yep. And then I'm going to say client dot, and you'll notice I get my IntelliSense here. You're also going to notice, and I'm going to highlight this for right now, is I get R. So I could actually access, if I wanted to, from the outside that Redis client. We'll talk more about that in a couple of minutes, but I just wanted to highlight that for right now. So I want to call save, so we'll go ahead and say save question.
I love the way the Visual Studio picks up, does the IntelliSense, even for the classes we create.
Absolutely.
Yeah.
Yep. And so what you're going to notice here is my title and answer. And by the way, forgive me for 2 seconds here. One of the things about Python is the semicolons at the end are optional, and I personally put them in. And when I was doing it, I actually stopped doing that. I got myself out of that, and it's a habit I like to keep myself in. So forgive me, I'm just going to go back and put the semicolons in.
It's fine.
Okay.
Yep.
In any event,
it's your C# background.
Exactly, it really is. So there's my Redis client. So now that's going to save into Redis. So it's now going to save our little question. And so now let's go in and note to self, add call to get the question. And get the question. There we go. So I want question equals client dot get question and title. I'm kind of going slightly out of order here. Client equals Redis.
Right. So you're clearing an instance of your class, making an object called client, and then you can call the methods of that object.
That's it. Okay. And now I'm just simply going to close all of this out by saying client equals Redis client, and we'll go in and say what did I call it? Answer. Answer equals client dot get answer, and then my title. Now, again, to sort of belabor the point here, what you're going to notice is that the only thing that we changed is just the data access part of this. So the call to render template stayed the same. The little if statement that we have right here stayed the same. So nothing else changed, just the call to the data access.
Yeah, all you did was the code that you moved into the class, basically now what you've done is you've written code that will declare an instance of that class, so creates an object, and then calls the method within the class that has the original code.
And that's exactly it. And so now I've got everything in place, and let's go ahead and Control F5 and chugga. And let's go in and create a question.
I'm ready for the drum roll here,
And who was the tallest U.S. president? And the answer is Lincoln. And let's go ahead and hit submit.
Fingers crossed. Drum roll, please. Dumpty, 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 dum. It's taking a little while.
You know, one of the things that I sometimes notice, oh, you are kidding me. All right.
Boom. Yeah. Well, you know, we're going to get there.
Hold on one second. Let me see. What did I do? Okay, so self-rep, self. Oh, well, I've got a problem here that needed to be self. I've got myself, my question, my title, my answer. All of that looks good. All of that looks good.
Do you need to import Redis in this class?
Oh, thank you. There we go. Import Redis. I was so focused on building the class
yes.
that I forgot about importing Redis. There you go. So now let's come back over to here and let's just get that 500 error off the screen. So now let's go back. President, who was the tallest president? And you know, let's make it U.S. president. You know, kind of make it correct here.
That's true.
Lincoln. And let's save. There we go. So now it saves. So now that we actually said, hey, yes, go get Redis. And then let's come back and say, question, president.
With an uppercase P.
With an uppercase P.
Kudos again to Ariel.
And let's go in and say Lincoln and hit submit answer.
Waiting.
And there we go.
There we go.
Now we're correct.
Woohoo!
Cool.
All right.
So let's just kind of go back real quick to that, just because I want to highlight one more time. And you know, one of the things to get yourself into the habit of right away is, you know, Visual Studio offers you this great IntelliSense and all this great color coding. And you really should just sort of train your brain to keep an eye out for that color coding. And if something doesn't change color the way that you expect it, let that sort of go, wait a minute, I was expecting something here and I didn't get it. So in the case of libraries like Redis, you're going to notice that will turn purple. And you're going to notice in the case of classes that's going to turn teal.
I guess that's sort of a teal blue, yeah.
Sure. Periwinkle. But in any event, you'll notice that. And you'll even notice that in the objects that we've created itself. And so actually, when I was typing all of this out, I knew that it was working because when I typed out Redis client, it immediately went to that teal. And I should have picked that up with the Redis. So Susan, 1,000 points for getting, yeah, there you go, for getting import Redis. And so now we've got all of that, which also, by the way, was on top of our views from before.
Yeah.
So there's the whole thing, is that now what we've done is we've just created this cool little object. And so when I call save question, do I need to know where it's being saved? And the answer is no. So let's kind of keep building right on top of that and start talking a bit about encapsulation. So encapsulation is a fantastic Scrabble word. It is, but it actually defines a great concept. So, you know, now that we know the syntax, how do we put our classes together and what are the best practices? So the number one rule when you're designing your objects is to keep tightly related things together.
Yes, I was very much taught an object serves a purpose. You know, keep it very focused. You don't sort of make an object for doing everything to do with databases.
Exactly.
That's too much.
Exactly, yep. And so you'll notice, for example, that a customer has a name, an address, a phone number, and a collection of orders. Now, let's sort of stop right here. And let's start talking a little bit about an order, because what's an order going to contain? It's going to contain things like ship date and total price and order date and things like that. And I really don't want that on the customer, because now my customer isn't just a customer. It's a customer with orders. So what I should do instead
I should probably have an order class.
Exactly, is create an order class. And that order class is then going to have an ID, a date. But, you know, an order, of course, is going to have
like I might order a book, a DVD, something.
A DVD? What's a DVD?
DVD. It was these old things. They came out with 8 tracks. Same thing.
Wow. Laser discs, anybody? In any event, so we're going to then have to create a separate class for our line items, because again, all of our line items are going to be different. And you start to notice how you're going to wind up using all of those different objects together, and each one is designed to serve another purpose. And so when in doubt, and I know that this sounds counterintuitive, but create another class that when your code is complex, and I know that this sort of runs in the face of everything that you might think, but it's true, is more often than not, if your code is too complex, you don't have enough classes. So don't be afraid to create a lot of classes.
It's not a bad idea to actually sit down and just grab a piece of paper when you're sort of thinking about what your application is going to be doing, and sort of sketch out little boxes and try to imagine. I mean, you can actually draw out full UML diagrams of object-oriented design with all your classes and methods. But even if you're not going to that level, take a piece of paper and sort of sketch it out. Just sort of go, well, what am I doing in there? We've got questions where people are retrieving. We're going to be talking to a database. Maybe we're going to divide our questions up into different categories of questions. So is category going to be its own class? So take your time and sketch that out and think about it. And you may discover as you get into the code, you start going, wow, this class is getting really big. Stop yourself and go, should that maybe be two separate classes? And you'll probably end up with a better design.
Absolutely. Now, one of the other cool things is that Python is what's known as weakly typed. There's sort of two concepts when you're talking about programming languages: strongly typed and weakly typed. So with strongly typed, if I'm going to declare a variable, I have to tell the environment up front, this is going to be that type of variable. And I'm going to oversimplify, please, in the Q&A. I'm not trying to get into inheritance and polymorphism and all of that. So I'm trying to keep this sentence I know is going to potentially be slightly technically inaccurate, but just kind of roll with me here. So when you're in a strongly typed language like C++ or like C#, essentially you can't change a variable type. That once you say that this is going to be a string, and once you say that this is going to be an integer, that variable itself can't change.
Oh, the Q&A is lighting up, Christopher. Sorry.
But Python and JavaScript are weakly typed, meaning that you don't have to tell the environment up front what the variable type is going to be, and in turn, you can change that on the fly. So you can take advantage of that. So you don't have to tell it that you're going to be using a particular object type. And, to kind of give you an analogy here, as long as it writes, I don't care what it is. So a marker can write and it has a color. Well, you know what? A quill can write.
Yep.
And a quill has color. So along those same lines, we can actually swap out our objects for other object types. And because of the fact that we don't have to tell it up front, hey, this is what you're going to be, or we could even potentially reuse a name, which is exactly what we're going to wind up seeing here, we can be able to have our application react to changes just by going in and updating one very simple line of code. So let's kind of dig in a little bit to our applications. And where's my Visual Studio? There's my Visual Studio. Okay. So first things first is I want to go back to our Redis client here, and I just want to talk a little bit about R, because R is going to be our Redis client, or it's going to be the actual Redis connection. And as we saw, we could access this from outside of that Redis client. And one of the things that we might decide is, you know what, really don't want to do that. That I want to make sure that nobody else can access this, that the only way that you're ever going to be able to save a question, to get a question, or to get an answer is by using the object and not being able to go directly to R. So you might decide to go in and just make that private. And this is one of those where it does become a bit of a design decision. And, we could spend literally the rest of the day starting to talk about all the different design decisions. But that's one of those things that you might decide to do. Now, in my case, just because I'm trying to keep it a little bit simpler, I'm just going to leave it the way that it is. But that definitely is something that you could do going forward.
That, in particular, about those sort of design decisions become a much bigger issue when you're working with a team of programmers.
Yeah.
Because what might actually happen is you might be the person who's the expert on Redis on the team and knows all about the database connection. So you're assigned the job of creating the classes that are going to talk to the database. But then you have some other programmers on the team who know absolutely nothing about how to manage connections to Redis. And all they know is they're great at designing awesome screens. And then they just say, get these values from the screen and just send them to the class.
Yep.
And they don't know what your class does. They don't know how your class talks to Redis and how it does the connection stuff. They don't need to know that. Remember, coming back to it's a black box. So the neat thing is when you're creating a class, you might actually be writing code that another programmer is going to call. And one of the advantages to that is you're hiding the complexity from them. I could be using that class that Christopher just created, and I might know nothing at all about Redis, and yet I can create these beautiful web pages and send all this code and have it saved in Redis without knowing how to do any Redis code. And that's actually one of the beauties of starting to introduce classes and objects into your code when you start working in teams.
And that's exactly it. So what you're going to notice here is, coming back into my code, there we go, is I'm actually going to rename this.
Okay.
And I'm going to make this a bit more generic. Because even by calling it Redis client, I'm telling you now, hey, this is going to be,
That's true. Maybe I don't know what a Redis is, and I'm going, what's Redis?
Yeah, exactly. So I'm actually going to rename that class to be simply client, and I'm just going to update my code here real quick. And I'm now just going to say client. And you'll actually notice that you could even go in and start renaming things. But in any event, so I'm just simply going to say import client. And then down below inside of my code, I'm just going to, instead of it calling Redis client, I'm now just going to generically call it client. Now, you might be wondering, well, why are you doing that, Christopher?
Maybe we know what's coming.
Exactly. Yeah, they're coming soon. What we're going to do is we're going to say from trivia MVA app models dot another type of client import client.
Maybe we don't want to stay with Redis all the way through. Maybe we want to try a different data source.
That's exactly it. And so by now just generically calling it client, the rest of my code can stay the same, and I only have to update this one little line right here. Okay, and just to kind of prove it real quick is I'm just going to real quick, lowercase question.
That's right.
Hockey. There we go. And let it load. How many minutes in a period? And I'm going to say 20. And I'm going to hit submit answer. Congratulations, you're correct. So I just want to prove that it does in fact still work, and our application is in fact in a working state. Cool. Well, let's continue breaking it then. So let's go ahead and take a break here. So we saw how to use objects. So we're going to take 10, and then we're going to come on back and actually, Susan's going to talk. I'm tired of talking.
There's people trying to telling you, so someone actually was complimenting your jokes in the Q&A. There are people waiting to talk to you in the Q&A, Christopher. So I better come and chat with you guys for a bit so Christopher can talk to you in the Q&A.
Exactly, yeah. So Susan's going to do databases, but we're going to take 10 minutes first because I'm about to have a coughing fit. Sorry, I'm still laughing. Danny in the back there says, you're unmuted, and both Susan and I immediately just looked down at our microphones like, oh, all right.
Okay.
Yeah, like we're looking for like a light or something. In any event, welcome back. I'm Christopher Harrison, that is Susan Ibach, and we're working our way through SQL, Python, and Flask. Well, we've seen the Python side of things. I think it's kind of now a perfect time to take a look at the SQL side of things. That we've been using Redis, but I think we want something that's going to be potentially a bit more powerful as far as a database goes. So, Susan, what do you know about SQL?
Well, you know what I was thinking? I was thinking the first thing I should do is I should bring up the slides for this chapter rather than the next chapter.
Oh, okay.
So I was just going to,
I will cause
keeping with our day,
distraction over here.
I'd say tell a joke, but I'm afraid where that might lead. So I will very quickly bring up the correct slide, and there we go. I am ready to go now.
All right, there we go.
Saving all of you from the next Christopher joke. But having said that, I'll have to let you tell a joke later because I'm sure there's a few people out there going, but I want to hear his jokes.
See, but we'll get to it.
All right, so we'll give you an opening later.
Yeah.
Yes, so what we want to do now is we've been talking about, structure of code a lot this morning, and we were just talking about, sort of using Redis as a client as one of the options of ways of storing data, and we covered that a lot in our last course. But another form of data that structure that you're going to end up dealing with at some point is going to be relational databases. So I want to take a little time and walk you through what exactly are relational databases, get you started, learn how to create a basic relational database so you can use that option in your code, and even talk a bit about, well, when's that the right decision? When would you go with Redis versus when should you go with something like a relational database? I saw a question in the QA about SQL, so we'll get into that as well, though that's a little bit more inside the next chapter. So what exactly is a relational database, really? so many websites, applications we build have a need to store different types of data. You might need to store, if you think about online stores, right? You need to be able to keep track of the customers, to keep track of orders, to keep track of their shipping information. Maybe you have product inventory you have to keep track of. You know, you run some sort of retail store and you have to keep track of the inventory. You've got it all for different stores, different products, sporting goods or books that you're selling. Or, you know, if you think about some of the applications we look at to look up movie reviews that keep track of all the different actors, so you can know, who's that guy that I saw that movie and it had that guy?
You know,
and
that
he was
guy,
in that movie?
You know that, that thing.
He was
that
in that movie.
And it had,
Yeah.
like, you know, the shooting and
then you always have to go pull up your computer to look up where you saw that actor and what movie was that. But that again, that requires storing different movies, different actors, maybe reviews of the different movies. You might have information if you're tracking at a university or a school to keep track of different students and what courses they took and what grades they got. So it's quite common to run into a lot of these different situations. Now what's interesting is even though they're all storing very different data, they all have data that has relationships between them. So if we take a glance at the slide, you can sort of see that if we have customers placing orders, well, there's a relationship between the customers and the orders. The customers are placing orders, the orders are placed by customers. If we're tracking store inventory with our application or website, then we would be tracking stores, and each store has one or more inventory items, and every inventory item is in a store somewhere. Apparently, inventory item is going to be the thing that requires me to have more caffeine to say. If you're thinking of actors in movies, you know, a movie has actors in it. Each actor is acting in movies. If you have students in courses, students are taking courses. Courses have students in them. So again, we have all these relationships between the different types of data we're storing. And when you see, that's sort of the magic moment, when you suddenly discover that you have different types of data and there's relationships between the different data you're storing, that's when you might want to go, you know, maybe it's time to step up from Redis, and now maybe it's time to consider something like a relational database. So this might be the time to kick it up a notch, go to a bigger, more structured format for storing your data. If all you want to do is store a single, a dozen questions and some answers, Redis is going to be fine for that. You just want to store some high scores, Redis is going to be fine for that. You know, poll results. But as soon as you start getting into, well, I have different polls for this team, and you can submit your polls and store the results and keep track of which user answered what. Now you need to know which user answered which question goes with which poll. Now those are relationships. So now again, that your brain starts going, time to think about a relational database as an option. So how does a relational database work? Well, you store your data in one or more tables. So a table is basically made up of a series of sort of columns, records, and rows. So if we go into this, you can see here that I've got sort of 3 records. I'm channeling my inner Christopher here with my Zoom it. So I've got 3 records here stored in a table called customer. Usually you steal the monitor if it has the touch working, and I can't get away with this. And then I've got another table here called order, and it's got 3 different records stored in it. And you can also see that within here I've got different columns. So I have records or rows, you know, one row for Bill, 1 row for Satya, 1 row for Susan. But you can also see I have columns. So I have a customer ID column, a date shipped column, an order date column. So that information basically determines what type of information I can store. So when I create a customer table, I have to say, what information do I want to keep track of for a customer? Their customer ID, their first name, their last name, their shipping address, what city do they live in, do they get any special discounts, do they have gold status or silver status, or do they get special privileges? Those would all be different columns in my table. And for each of those columns, I'm also going to have to specify a data type. Relational databases will force you, they're what we call strongly typed. We were talking earlier about how Python is a weakly typed programming language. When you declare a variable, you don't have to say if it's going to store an integer or string. Relational databases will force you to say, this column, customer name, is going to store a string. And you even have to specify how big a string. So it's quite strict about how you define what data is going to be stored there. If you have a customer ID, you're going to have to tell the database that customer ID is at an integer, like 1, 2, 3, 4, or is it an ID like SI back? You know, so like an abbreviation, then it would have to be character. You can have date data types. Those are probably the most common: numeric values, character values, and date types. So you need to specify a table name. You need to specify the columns you want and the data types for each of those columns. And finally, the last thing you have to specify when you create a table is you have to specify if that column is mandatory or not. So if we go back to the slide for a second here, you might possibly end up in a situation where maybe I'm moving. So I don't know where Susan lives, what country. Would I still be allowed to store a record in the customer table for Susan if you didn't have her city and country information? Imagine you walk into a retail store. These days it's quite common. They'll say, you purchase something, go, can I please have your zip code or your postal code? And because they want to keep information about where people shopping at your store, where they live, and so they know where to advertise and things like that.
Marketing. It's all about marketing.
It is about the marketing, exactly. But, you might say, no, I'm not going to give you that information. Well, are I still going to store the customer information even if I don't have your postal code? So is postal code required? Is it mandatory? So that's something else we have to think about is for each column, is it a required field? Typically something like an ID field, customer ID. Yeah, every customer will be assigned an ID. Every customer probably I have to enter some sort of name for them. But there might be other fields like, are they gold status? That's the kind of thing. I might just say, if we don't know, leave it blank. All right, so one of the other things is you can actually end up with multiple tables. You'll end up with 1, 2, 3, 4 different tables as you go along. So you might have students, courses, and grades. You might have customers and orders. So lots of different structures you can end up with depending on what you need to do inside your application and the type of data you need to keep track of. Now, one of the interesting things is this is a relational database. And that word relational implies there's a relation between the data. And the way we implement that relation in our data is we actually have some sort of column that's the same in both of the tables. Now, that's because they store related data. The columns don't actually have to have the same name. It's possible that it's called customer ID in one table, it's called ID in the other table. It can make your life a little easier if you actually use the same column names because it'll make it easier for you to remember what they have in common. But just so you know, that's not actually a requirement. So if we take a glance at the slide, you can see here that on the customer table, for every customer, I know their customer ID, name, city, and country. Mm-hmm. For every single order, I look at order, I know their order ID, the order date, so the date the order was placed, I know which customer placed the order, and the date it was shipped. And so, but instead of just storing the name of the customer and all the information about the customer on every single order, all I do is I store the customer ID of the person who placed the order, so customer ID number 1. And based on that, I can then go look up in the customer table, and I can see that customer ID 1, oh, that's Bill. He lives in Seattle in the USA. Mm-hmm. So when I need extra details about the customer who placed that order, I just go get it from the customer table as needed. So those two columns that sync up allow us to make that relation. That's what makes it a relational database. So that's a very key concept when we talk about relational databases. So in this one, I said I was just sort of putting it out, which orders were placed by the customer named Bill. So if you look at that data, Christopher, glancing at it, if I know Bill calls me up on the phone and I'm working in customer service and I'm being asked, hey, I better look up his orders so I can see what he might be complaining or asking about. So looking at the slide, how do you figure out which orders came from Bill?
Well, if I go look at the order table, you're going to notice that there's the customer ID column, and that would seem to match up to customer ID inside a customer.
Yeah, right. And since we know Bill is customer ID 1, then we just go find all the orders with customer ID 1, and now we know these are the 2 orders placed by Bill, and we can see that he had an order that he placed in January 2000 that was only shipped in 2014.
So 14 years.
14 years to get that. So maybe that's why he's calling. And if I want to know the name of the customer who placed order 1002, then again, similar sort of concept. I just go find order ID 1002. I look up the customer ID in that record, and then I can go find out who is that customer, and that turns out that was Satya Nadella, CEO of Microsoft.
Okay.
Now, sometimes the relationships can get a little more complicated. So here's one where I actually have 3 different tables. And we sometimes call these, the correct terminology for these is foreign keys. So the foreign key customer ID in the order table points to the key in the customer table, so I can tell which records go together. So here I actually have 3 tables. And I can see students, I can see courses, and I see what grades people got in different courses. And I can use the student ID to see which grade goes with which student. I can use a course ID to see which grade goes with which course. But how do we actually know which students took which courses? There's no relationship between student and course when you look at those two tables. There's no column that exists in both student and course table. So what we actually have to do in that situation is we have to go through the grade table to figure out which student took which course. This is sometimes called an intersection table. It comes up with something called many-to-many relationships because students can take many courses and each course is taken by many students. So this will happen very naturally in your data situation. So you'll encounter this quite often. But if you think about it, in the end, you can usually follow it through fairly simply again. So I'm going to put you on the spot again if I can, Christopher.
Okay, do I have a choice?
No, you don't have a choice. Let's be clear about that.
Okay.
All right, so we can bring up a slide, and I'll ask you, what grade did I get for my Python and Flask course?
Well, that's a little harder because there's a couple of tables that are in the way there that I am going to notice that we still have student ID and we still have student ID down there on grade.
And we can see
So,
there's Susan, right? And there's the Python and Flask course.
Yep.
But how do I link those together?
So, well, I'm going to guess that it's probably both the course ID and the student ID.
So, yep.
So it looks like you got an A. Well done.
Yes, because the course ID 101 in the grade table shows up there. And sure enough, that is for student ID 2, and that's me.
Yep.
So yeah, I got an A.
Yes.
I think if you wrote in the course yourself, you might actually get an A+, but I guess I must have blown a demo somewhere along the way.
Hey, be nice.
Hey, we've all been there. And if I needed to figure out, say, the names of the students who'd taken the Introduction to Python course, well, again, I would go through that sort of grades table would help me figure it out. So I go, the Intro to Python course, that's this course here, it's course ID 100. So then I can go down to the grades table and say, let's find all the records with course ID 100. So that tells me these two are grades for that course. What student IDs do they go with? And then I can go and figure out that it was Usha and Susan who took that course. So said, it's a more complicated relationship, but if you just take your time, sometimes actually sketching it out on paper can actually help you understand the relationships.
Absolutely.
That's all in this episode. I hope this tutorial was helpful. In the next episode, we will continue with the remaining part of this course, which is creating website with Python, Flask and SQL. Is your mind ringing with questions, queries or doubts? Do you wish to learn more? Then visit our website www.millionlights.org and post your questions on our forum. We will be really happy to clear all your doubts. If you missed anything and want to rewatch it, you can download it from our website or can watch online as well. You can also participate in our webinars, discussions with the subject experts, as well as get Microsoft certification on various courses through our website. You can also find us on Facebook by the name Millionlights and also on Twitter. For more such interesting tutorials on coding, app development, programming, and building rich UIs, keep watching Microsoft Hour of Code, brought to you by Millionlights. Thank you.